Now let's talk about solving trig equations. One of the first things to look for in these is whether you've got an angle multiplier or not. In this problem we don't have an angle multiplier. That makes it a little bit easier. The next thing you should look at is the interval that you're trying to solve over. This one is given in degrees, so that means we want to solve for an angle in degrees. That also means if we're trying to use our calculator and use an inverse trig function, that we'd want to have it in degree mode. The first thing we want to do with this is, since we just have one trig function here, we want to solve this equation for the trig function. That means we want to have cosine of x by itself on one side. We're going to subtract 1 from each side, and then we can divide both sides by the square root of 2. That gives us cosine of x equals negative 1 over the square root of 2. Since we're looking for all the solutions between 0 and 360 degrees, we want to think about what quadrants this is going to be in. Where cosine is negative would be in either the second quadrant or the third quadrant. What we can do first is find the reference angle and then find the second and third quadrant angles from there. If we look at where cosine of x is equal to positive 1 over the square root of 2, that would be at 45 degrees. That's our reference angle. To get our second quadrant angle, we would take 180 degrees minus our reference angle. 180 minus 45 would be 135 degrees. To get our third quadrant angle, we would take 180 degrees plus our reference angle. That would give us 225 degrees. Those are our two solutions that are between 0 and 360. In number 18, we're looking for all the exact solutions between 0 and 2 pi. That means our answers will be in radians. The other thing with this problem is that we do have an angle multiplier. We have the cosine squared of 3x and the cosine of 3x. The first thing to do is look at what type of equation we have. We have a cosine squared and a cosine. We already have a 0 on one side of this equation, so now we want to try and factor this expression. If you want to substitute in something else for cosine, you can. Let's not use x in this one because we already have an x here. So if we substitute something like y to stand for the cosine, that would give us 2y squared minus y minus 1 equals 0. This just might be a little bit easier to think about the factoring this way. To get a 2y squared, that means we'd have to have a 2y and a y. To get a 1, we'd have to have 1's both of these two places, and then we have to think about the signs here and here so that we'll end up with a negative y. And how that's going to work is if we have a negative here and a positive here. That's our factoring. Now we can go back and put in the cosine of 3x in place of the y's. That would give us 2 times the cosine of 3x plus 1 and the cosine of 3x minus 1. Now we want to take each factor and set it equal to 0. We're going to take and solve this for the cosine of 3x. That's going to give us negative 1/2. We solve this one for the cosine of 3x, that gives us positive 1. And remember, when you have an angle multiplier, you want to solve for the angle with the multiplier first. Where this would be true, where our cosine is equal to negative 1/2, that's going to be in the second and third quadrant. We're looking for exact values in radians, so this would be at either 2 pi over 3 or at 4 pi over 3. Those would be our answers for the 3x. And where cosine is equal to 1, that happens at 0. Now what we want to do is write down all of the solutions for 3x. We're going to take the values here and add 2 pi n to each one. we'd have 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n, and then 0 plus 2 pi n, so we could just write that as 2 pi n. Those are all of our solutions for 3x. Now to get just x, we're going to take everything here and divide it by 3. So in here we're going to take each one of these terms and divide by 3. This one is going to give us 2 pi over 9. This is going to give us 2 pi over 3 times n. This would be 4 pi over 9 plus 2 pi over 3 times n. And this one would just be 2 pi over 3 times n. This gives us all the solutions for x. What we really want is the solutions between 0 and 2 pi. To figure out how many solutions we're looking for, we can take our solutions from back here. We had 3 of them. Since our angle multiplier is 3, we would multiply this number of solutions by 3. So actually we're looking for 9 solutions between 0 and 2 pi. We're going to take each one of these and put in different numbers for n. What we want to do is put in 0 for n, and then 1 and 2 for each one of these, and that's going to give us our 9 solutions. This is going to make a pretty long list. If n is 0 here, we just get 2 pi over 9. If n is 1, then we have 2 pi over 9 plus 2 pi over 3. That's going to give us 8 pi over 9. Then if n is 2 here, we've got 2 pi over 9 plus 4 pi over 3. That would work out to 14 pi over 9. And then we can move on to this one. If n is 0, this would just be 4 pi over 9. If n is 1, that would work out to 10 pi over 9. And if n is 2, that would work out to 16 pi over 9. And then for this last one, if n is 0, we just get 0. If n is 1, we get 2 pi over 3. And if n is 2, we get 4 pi over 3. Now with each of these, we could have kept going and put in another one, but with each one of these, if we went another step with the n, then we would have ended up with something that was more than 2 pi. In number 19, we also have an angle multiplier, and this time we're trying to find all solutions in degrees, and we want to round our answer to 1 decimal place. This time we're not looking for exact solutions, we're looking for approximate solutions. That means that we're going to be using our calculator somehow. First of all, if we think we're going to be using our calculator, this is one of our reciprocal functions. Cosecant is the reciprocal of sine. If cosecant is equal to 1, we take the reciprocal of that, it would still be 1. So we could switch this to sine, and if we do the reciprocal of this, the reciprocal of 1 is 1. So we still get 1. Then first of all, we're just trying to solve for the 4x. We can take the square root of both sides. When we do that, on this side we have to do plus or minus. That would give us the sine of 4x is equal to plus or minus 1. For this to happen in between 0 and 360, that means our 4x would either have to be 90 degrees or 270 degrees. At 90 degrees, the sign would be positive 1. At 270, it would be negative 1. Now we want to take this and write all the solutions for 4x. That would be 90 plus 360n and 270 plus 360n. Then we can take this and solve it for x by dividing everything by 4. In this one we're looking for all solutions, so this will be our last step. If we take 90 and divide by 4, that's going to give us 22.5 degrees. 360 divided by 4 is 90. And then here if we take 270 and divide by 4, that gives us 67.5. 360 divided by 4 is 90. There are all our solutions for x. In number 20, we're going to have to use one of our identities, because we have 2 different arguments on the 2 sides. Here we have the sine of 2x, and here we have the sine of x. We can't really do anything with this when we've got 2 different angles, Let's use our double angle identity to rewrite this side. The sine of 2x would be the same as 2 sine x cosine x. Now we've got two different functions. We've got both a sine x and a cosine x. We need to get everything on the same side so that we have a 0 on the other side. To do that, I'm just going to subtract this whole term from both sides. Now we have a 0 on the right side. And now we can factor this because both of these have sine. So we can factor that out. That gives us sine of x times 2 cosine of x minus the square root of 3 equals 0. Now we can take each factor and set it equal to 0. This time we're trying to find all exact solutions in radians. Exact solution for sine of x equals 0, that would happen at either 0 or at pi. This one, if we solve this for cosine of x, that would give us cosine of x equals the square root of 3 over 2. Cosine's positive in the first and fourth quadrants. The first quadrant angle that would have this cosine in radians would be pi over 6. And then we want the fourth quadrant angle that's in this same family, that would be 11 pi over 6. We could get that by taking 2 pi minus pi over 6. Now we've got 4 solutions that are between 0 and 2 pi. To write out all of our exact solutions, we just take each one of these and add 2 pi n to it. So 0 plus 2 pi n would just be 2 pi n. And then we would have pi plus 2 pi n. We'd have pi over 6 plus 2 pi n. And 11 pi over 6 plus 2 pi n.